Good morning, good afternoon, or good evening, whether you're watching live or archived, and welcome to a Nautel Webinar Thursday. Doesn't have the same alliteration as the ones I'm used to doing, but we're going to have some fun with it. We are talking about the new VX series. Kind of cool the way we're hitting at this, because this is sort of a recap of what we did almost exactly a year ago, except instead of talking about a science project, now we've got actual shipping transmitter, and it's a whole lot more fun and changes the perspective. Got two excellent, smart guys with me today. You got the handsome and talented Mr. Matt Herdon. Matt is the product manager for the VX series. Matt, did I get that right?
Yes, indeedy.
Always
First
good
time
when
ever.
Yeah. Well, I alternate between project manager and product manager, and he gently corrects me every time. And we've got one of our top engineering talents, Mr. Justin Jamieson. Justin, welcome.
Well, thank you, Jeff.
Always good when you can find the mic and the camera all at once. So we're going to run through it. Matt, I'm going to kind of let you take lead on it, and I'll just click the slides as you nod your head and tell me that I need to get going. We will do the mandatory housekeeping stuff first. I say we're going to talk about the agenda. This will be recorded, and you do have the ability to ask questions, as with all of our webinars. So on your webinar interface, you've got the little place where you can type in a question and hit the send button. When you do that, it'll pop up on my screen, and we can absolutely try to handle them as we go. I know Matt has his analog PDA right at hand, so he's able to take notes on anything that we can't hit or don't have time to cover in the course of the next hour. So on that note, let's roll. Matt, when the VX series has been kind of an evolution, if you will.
Yep. Sorry, I thought you were going to say more. Yeah, and so let's dive into the first thing. So, we've got this agenda where we're going to talk about where it came from, what we saw as being the driving forces to sort of make us think about it, and then we're going to show you the product, and then with Justin's lead, we'll go into a tech tour to sort of go in as deep as you want, because Justin's the guy. So let's flip to the next slide. And so I think most of you are familiar with the VS series. You can actually see the corner of one right there. I have it stuck to the wall there. That's my demo machine, and so that's a VS 300, and that's been a very, very successful product for Nautel, and it has the three models. Well, three and a secret one, which we don't talk about too much, and that's a 300, a 1, and a 2.5, and that's been around for nearly 13 years now, and it was famous for sort of really bringing some big transmitter features down to a small box, and that was the exciting part, where you had some sort of pretty powerful capabilities. And over the years, we've clicked up to, I think it's over 7,000 customers now running transmitters around the world. So here we are a while later, or were a while later, and there's obviously been some big steps forward in terms of the technology, and I'm going to let Justin speak to things like power density, but all sorts of things like the creation of chips that could do more, and being able to bring things down in size, and that was the engineering opportunity. And then the other thing is the tools, the design tools, and again, Justin will go into the details of that. And then we have this big backlog of customer requests and refinements of what they had found out with the VS, and said, hey, what would be really nice would be this. And so we had a pretty sizable backlog of requests and intelligence, if you like, about what was great and what was not so great about the VS. Keep the good stuff, add the cool stuff.
And I'm going to throw in the side note that it sort of happened simultaneously, and it certainly wasn't by any choice on our side, but the the retiring of Flash and the need for a new user interface. And we'll do a totally different webinar on that. So that's a whole different concept. But
Absolutely.
the two kind of fed off each other over the past year or two. So it's been kind of fun to watch.
Yeah. So the things that were in the pool of stuff that we could do would be better packaging or better form factor, efficiency, maintenance, the control, the UI. So things like the front panel. Right now, on the VS, you've got the crystal fonts, and could we do better? Was there something that was more reliable, bigger, easier to read, easier to use? Power supplies, taking advantage of new stuff that's out there. And then quieter, so the sound is a big issue for a lot of people, and then affordability. And so those are some of the aspects that we're going to delve into in this session.
And that's one just little side note before I click to the next slide that I wanted to bring in. And Matt mentioned it too, the backlog of customer requests. I mean, every time one of you folks reaches out to me on Facebook or in LinkedIn or via email or over a beer at a trade show, I mean, we keep notes and records of all of this stuff. So like Aaron last week was asking me about something. Marco's brought up several things. Alex is always hitting me with, and Alex, bless his heart, will be a little less tactful about it than, you really should do this. It'll be more like, what the heck were you thinking when you did this? And so that's exactly how I'll bring it over to Matt. Say, what the heck were we thinking when we did this? So, that's the kind of thing that we live and die by this feedback. So the more y'all give us, the more closely we can make the product fit your requirements. Now, obviously, we're not going to do it all. I think I had a request to paint transmitter different colors, and that gets to be logistically a little more challenging.
Spray it. No, it's a spray bomb. One of the things I joined the company in 2016 for NAB 2016, my first day on the job in Las Vegas, and the first thing I did when I got back was to actually go through all the VS customer support issues on the VS, so that I could pull from that the things that really were causing a lot of pain and grief and cost, so that was a good place to start.
Yep. So I mean, it definitely, keep the feedback coming by all means. I mean, even if I start to look a little cross-eyed because I don't understand what you're saying, I can certainly find somebody who does.
Yeah. Okay. So this is it. If you haven't seen it before, this is the 2 kilowatt model, which is the top model in the smaller form factor, the 2RU form factor, and you're going to see pictures of the larger form factor, which goes from 3 to 6 kilowatts. And the goals were to have a compact, efficient, affordable analog FM transmitter. We wanted to be rack mount, and those were key design criteria based on your feedback. So let's dive in.
And for what it's worth, whenever we come on to something like this, I mean, obviously, first there's the business study. Can we do something like this and actually make a living doing it? Because, well, feeding Justin and the rest of us is kind of critical. So that's one thing. But then we'll start basically collating all of the requirements and the design. What's the technical frame for it, Matt? The big spreadsheet.
Stakeholder needs.
Yeah, stakeholder needs. It's like what, 2,000 line items in that thing?
It was too scary to count them. I stopped counting, but that's mine. I own the stakeholder needs, and everything we get gets put into that, and they get tied to product requirements that have specs associated with those, and then those turn into work elements for people like Justin, who actually go and do the hard work. And so it's an interesting process, and this is it was a very one of the first times we did it in the way we did it this time, and I think it worked out quite well.
Yeah, I mean, it made for an interesting process at times, because a lot of us can get pretty passionate about what we think is the perfect solution.
Yeah.
And we don't always necessarily agree on that, so it was pretty entertaining.
Indeed. So the important thing, it was a ground up design, and I'm going to hand it off, I think, over to Justin here to sort of lead, and I'll jump in. So Justin, why don't you? Oh, sorry, I'm going to point. No, I got to point the other way. There we go, Justin. This is it's like Family Squares or some game show like that.
Excellent,
Yeah.
thanks, Matt. So just to speak to this slide and the fact that this is a ground up kind of completely new design, you won't find really anything legacy carried over from our previous series like VS or our GV or MV light transmitters. We really wanted to look at the breadth of new technological improvements and really start with a fresh baseline with technologies that correlated with each other. So that's a combination of, you know, a power supply and a PA that work well together, and then combining that with a thermal control system with variable speed fans, and all of that goes together to work in harmony. And when you can start from a fresh slate, that really enables you to build a much better system from the ground up.
And it's worth noting too that we started shipping, because Marco's asked already about the 6RU units, the higher power ones, which we'll get to. But these guys, the 150 to 2 kilowatts, started shipping about a month and a half, 2 months ago, a month, in that range.
Yeah.
Yeah. Okay. Sorry. Carry on, Justin.
Yeah. So I think, you know, in general, that did pose a design challenge for us, where we were doing so much new design work, and that really was kind of one of the major hurdles to overcome in this project. But in general, I think we've got a better product because of it, because we've been able to make decisions on kind of a holistic, big picture from a transmitter architecture. Exactly.
Yeah, a bit of a house cleaning, and I think that was very exciting.
And certainly
we go into more detail in the next little bits. So yeah.
So one of the main, I can speak to this. One of the main challenges when shrinking down a transmitter, comparing, you know, this smaller 2RU 2 kilowatt to kind of the much bigger VS 2.5, is how do we still maintain a layout and a mechanical structure that allows our customers to service their transmitter and to prevent any complexities that come along from hiding and kind of obfuscating pieces of the transmitter below other things. If anyone's seen the internals of a cell phone lately, you can kind of appreciate the fact that most aren't being designed for any level of serviceability, because it's really cram as much in as possible. So we had to maintain that because we pride ourselves on that serviceability.
I was going to add as well, because the you know, one of the things that people commented on is how deep the VS transmitters were, and so we've also made the challenge even more intense by bringing this to a 20-inch depth on this unit here, and so that sort of just racked it up right there. Oh, bad pun, sorry.
Yeah, absolutely. So we've shrunk every dimension except for the standard 19-inch form factor for width. So the fact that we've tried to kind of include as much as we can from every perspective, improve our watts per cubic inch, our dollars per watt, all of those key metrics, and from a necessity that comes around for that, also improve our efficiency. It really took a lot of time to figure out how to lay this out in a way that still allows it to be accessible and serviceable. So yeah, we can.
Sorry about
Next
that.
slide.
Not yet. Elaine brings up the point that the sizing also impacted weight too. I mean, the VX2, the 2 kilowatt, weighs less than our old VS300.
That's correct.
I could happily backpack one of these up the mountain. It's not a big hardship. I just tuck one under each arm. I'm on my way.
Now, before Matt gets too carried away with that, I've got a 1.5 kilowatt upstairs that needs to be finished getting the preset set up, and it's going up the hill to Cove. And Matt's volunteered, so you know, we may take him up on that. It's 1.5 miles up that hill.
You go in the truck, and I'll follow you just by foot. Yeah.
Yep.
need to get fit for NAB. So yeah, why not?
There you go. Okay, Justin.
Yeah, so kind of moving on to this slide, some of the technology that we've been able to introduce. One thing that we've heard in the past is that customers want to be able to replace common components that tend to fail in the field. Making our power amplifier solderless was a big design goal for this project, because ultimately when you're going up to the hill and you're trying to get there, you don't always have every tool accessible to you. And if you can omit the fact that you need a soldering iron to replace your PA, that's extremely helpful. So our PA replacements for this entire VX line is completely solderless. And in fact, all you need is a #1 Phillips screwdriver to do that complete replacement. Continuing.
Giving a quick plug out to the folks at Innovonics, I've totally disassembled one of these transmitters with the Innovonics hand #1 screwdrivers. So if you see
Nice.
Ben Barber or the folks at a trade show, grab one of these, because this will be your new VX transmitter tool. William asked if the smaller VX series transmitters come with a set of rack slides like the VS series did, and leaving those off was a conscious decision. We had several spirited discussions, as I said, differences of opinion. And ultimately, I think leaving the rack slides out was the better solution. #1, we made the front heavy enough. We used some serious heavyweight aluminum, so it will support the entire weight from the front ears. You don't need rear support.
That's correct. And that front panel is one continuous piece of aluminum extrusion that then is machined to get all the features that we need there. So that was a big move. And like I said with previously, when we're trying to compact everything down, every inch matters. And putting rack slides on the sides requires eating up some valuable room within the transmitter to actually make that happen. So that
those Jonathan rack slides are also $100 a pop. So it, if you can knock the cost down, it doesn't hurt either.
Exactly.
William says, thank you. Most people didn't install them anyway. And I know there were lots of videos about it, because they were an interesting challenge. So having something that with a front panel solid enough to mount to is awesome. All right, carry on, please.
Exactly. Continuing on the front panel, that's really valuable real estate for us, and we really didn't give up anything, I think, there. Making it so that you could remove and service your power supply without actually having to open up your transmitter was a big key feature for us as well, since that tends to also be a component that over the life of the transmitter is likely to fail versus other components in the system. And the air filter as well was another thing that we wanted to make easily accessible, and can be completely removed and is washable from the front and can be easily cleaned and reinstalled. And again,
Exactly.
just a #1 Phillips screwdriver.
Yeah.
We tried to keep, that was something we heard back from our customer service department and from our customers, that you don't have everything in your toolbox, and we've tried to avoid any kind of custom hardware where it's not absolutely necessary. Generally,
no more 3mm Allen keys to get your fan filter off.
No, exactly. I think there is one entire hex key needed for this entire transmitter. That's to remove the set screw in the knob on the front, and we've included that as part of the ancillary kit. So we don't want you to be left with tools that you don't have to do the job you need to do.
William mentions that they still have a bag of 3mm hex wrenches that they've distributed to various VS equipped sites over the years. So
yep.
And again, this is one of those that we got the feedback, and we do listen.
Exactly. So coming back to kind of the core focus, this is an excellent graphic that compares what we had previously with our VS2.5 to what we're offering with our VX2. We've substantially reduced weight and really significantly the volume of the transmitter, so that it fits into more sites, so that you can have more transmitters in a single rack, and so that you're not breaking your back to install it. Recognizing that a lot of transmitter sites, when you're heading up, it's just you there, and we want it to be able to be easily installed or removed in such a way that you're not breaking your back while doing it.
Yep. And I mean, that's one of those, there's been a lot of write-ups over the years about different ways. Like a lot of folks will take a 1U server rack, install it upside down, and or server shelf rather, and install it upside down to put the VS 2.5 on, rather than trying to figure out a way to support it while you're installing it at 65 pounds. And if you don't have it at exactly waist level, then you know, shoulder height or higher, that gets to be a challenge. So yeah, dropping the weight by a factor of over 2 times is huge.
Yeah.
Right, moving on. There we go. So power chain. Oh, one other thing on service too. One of the cool things about the low power VX specifically, and when I say low power, 2 kilowatts and down, is everything is top accessible. There's no more crawling underneath it to get to the power supply or to the PAs, depending on your power level. So it's all right there when you look in the top. Okay, sorry, carry on.
Yeah, no, and I would like to expand on that as well, Jeff. When it comes to the bigger 6RU boxes, within what we're calling the amplifier section or kind of the big power block, we've also made the most common components that get replaced, PAs, as accessible as possible. I don't think we have a picture in this slide or in this slide deck, but we've made a really awesome, top panel comes off, all 6 PAs are right there accessible for you to access, and furthermore the power supplies are also front removable. So we've tried to maintain that all the way up through the series where we can.
And if you're going to be at NAB, you can come by the booth, and we've got a VX6, I think it is, with a acrylic panel across the top, so you can sort of see inside and check it out.
Absolutely. If you're by the booth.
Too many of the future slides, because otherwise that'll be going through.
Yeah, we can keep rolling.
Yeah, we'll talk more to that later. But with regards to kind of some key technologies that enabled what we're doing here, this power supply that we're using is a key component of that. So it's a 80 plus titanium grade power supply. So that's a peak efficiency of 96%. So we've really, that's a key focus, is the less heat that we generate in this form factor. That's really the only way that we can achieve what we're looking at here. So every % of efficiency, both on the amplifier side and on the AC to DC side, is really key.
And also how we remove the heat, and we'll talk to that in a little bit as well. One thing I did want to ask about, so the original VS, the first iteration of the VS used the Tektral CUI supply, which early iterations, there's no secret in the industry. We had some challenges with them. We got most of it fixed by getting them upgraded to Platinum series. And then when Tektral stopped making them, we went to the Lineage, which I think is ABB now. Is that right?
That's correct.
And we started with Platinum in them, and then now we're Titanium. So beyond the 2% efficiency, is there any significant difference between them?
Yeah, so one of the improvements for 80 plus titanium is that you actually achieve more efficiency across the output range of the power supply. So 80 plus rates it for different parameters at, I think, 25, 50%, and 100% load. So depending on which transmitter model you have and in which conditions you're operating, because our PA performance varies due to load and other operating parameters, that move to titanium improves efficiency a lot across the band. So even though at that kind of rating point where it's only a 2% difference, as you start to pull back on the output power, that is key there. So where we have models in this series that go across 150 watts all the way up now to 6 kilowatts, we really needed that to maintain efficiency wherever we could.
And one of the other things that I do want to bring up, and we'll talk to it, I'm sure, later, or various other points. One of the changes that was made on these historically, and I know I've seen discussions where some other manufacturers have done the same thing. Historically, when you hit the off button, the power supply fans all stop. Well, anybody who knows anything about power supplies knows that an unloaded power supply tends to saturate and run a lot hotter sometimes than a loaded supply. So one of the things we've done differently on the VX is that the power supply fans run in idle mode even when the transmitter's off, just to keep moving the air through and keep it from getting warm. So that's, again, just one of those things that we've learned as we went, so to speak, yeah?
Exactly. You have to take into account that there's passive dissipations within not only the power supply, but all the components in the system that continue operating. And while a lot of them have fairly substantial temperature ratings, they also generally derate lifespan with high temperatures. So the options are try to provoke longevity where we can by flushing air through both the main cavity and the power supply. Or let it get hotter in an idle mode and risk kind of issues to longevity. So
And we're
that's
going to do
where we had to make
a
that
bit
compromise.
more of a deep dive into the thermal properties in a few slides. So
Yep, exactly. Let's see, Aaron wondered if the fact that the PS fan's always running is something that should be on a warning side of some kind on the front panel. So the only challenge from a warning perspective, I guess, would be that there is some noise level to it. It's not huge, but you do notice it. So
the noise level is the noise is coming from the fan on the far side there in that image. So it's the one of the two fans that is going to be cooling the cavity, and that one is the one that's going to run at about 3,000 RPM usually, all by itself. And then as you start turning the RF on, then the other fan will kick in, and they'll be roughly the same speed. But I don't think you'll really hear the power supply noise at all. It's all in the bigger fan.
Okay. All right. Very cool. I never did wave my ear around it. Aaron's saying that point is when you turn a device off, you expect it to be off, and if you still hear noise coming out, it'd be cool if there was a note telling you why. So that's something to think about. Maybe we add a little slide to the box, but that's a good point, Aaron. Thank you. All right, moving on.
So yeah, a couple features here that we wanted to highlight. So we are continuing to support our Orban inside that I'm sure many of you are familiar with, our kind of optional audio processor to purchase with your transmitter. So that would be installed there kind of over top of that shroud that's around the power supply. And then one of the big innovations that we brought forward from a new device that we kind of designed our system around is our DSP, our digital signal processor. And that's a combo device where it's running 3 cores, 2 of which are DSPs, 1 of which is an ARM processor. And that dual core DSP has actually enabled us to plan for some possible future expansion, as we've only actually to this day deployed 1 core on that DSP. So we're holding that other one back in kind of a preparedness for some possible future applications so that we don't run out of that processing headroom that we might have had on previous devices. Furthermore,
I'll throw the question in there because it's already been asked, and we'll address it again. And Matt gave me the very stern fatherly response the other day when I asked. But so the question as put up by William was future plans for HD.
Let me answer that one.
Because he gave me the stern fatherly lecture.
That's right. Yeah. This is, repeat after me, an analog FM compact rack mount transmitter. That we had a very, very focused approach towards the design, and we talked about HD a lot in the beginning and decided to take it out of the design because it was too limiting from the perspective of doing right by the analog aspect of it. And so as far as that's concerned, if we were to revisit that, that's not even a conversation we're having right now. So we want to make sure that people understand that this is the sole focus of this particular unit, and that if anything changes in the future, it changes, but that's where we're at right now. And
it's also fair enough to say that we are still building the VS for HD requirements.
Yeah, exactly. So, we didn't feel that there was that, intense reason to sort of load up too much responsibility on this design for being able to do this over here when we knew we could do an amazing job of an analog FM transmitter. And that's where we wanted to sort of knock it out of the park and give people something really amazing right off the bat.
Okay. Now, back to the separate analog audio card, which is, and I want to drop a note in here because as anybody that's ever run into a certain processor that occasionally needs some of the caps put in, you know that you can throw some DC out there, and some front ends react poorly to that. And having to swap out a $1,500 combined computer / audio / controller board because you lost the front end out of one IC in the analog audio portion has been a frustration we've heard once or twice before. So separate circuit board, and I'll let Justin address the tech behind it.
Yeah, so effectively we could divide our sources between what comes in as a digital source via AES and what comes in via analog sources like just regular analog audio or through your composite MPX. So recognizing that all of those signals that come in from an analog perspective tend to be where we suffer the most risk to destruction via transients or any sort of upstream failure. We separated that off so that that card could be replaced at a much lower cost to the customer and a much simpler replacement. The benefit as well there is that we separate all of our analog circuitry, all of our kind of input buffers and all that jazz, to a completely separate board that also hides it from a lot of the signal interference that might be present on a digital board like our exciter controller. So there's a lot of benefits that we get to moving that off to its own separate card, and it really helps to maintain our very competitive audio specifications and also save you guys money if a cap starts to fail and feeds DC to your MPX input.
Now, Williams asked if it has AOIP input, so audio over IP, streaming, etc.
So I think I'll let Matt speak to that one, since I think that's a roadmap item.
Yeah, so what we'll see, there's a slide further on of what's not in the VX yet. And one of those things is the audio player. So we've gone with a particular variant of Linux that allows us to do a lot of the things that we want to do, and we're developing an audio driver that will enable us to have an audio player. We already have a player because we developed that quite a while ago, but to have that player actually do anything, you got to have an audio driver for the Linux you're running off. And so that's right in process now. We're cautiously optimistic, but it ain't over until it's over. So we want to, but that is the intention. So audio over IP is enabled by all of that, and so that is a definite plan. When it's going to be available, as a product manager, as a project manager, I would say I can't tell you yet because I don't know.
And that's something else that, and Justin had mentioned the dual core processors before, but we've got the headroom in here to add things like this. So again, just require the feedback. I mean, this one we already know we're going to do.
Yep,
it's just
absolutely.
just a matter of making sure. And somebody put it once, one of our sales guys, I don't know if Wilson's on the call or not, I haven't scrolled down the attendee list recently, but he said at some point you've just got to shoot the engineers and start shipping a product, because and bless their hearts, left to their own designs, they'll keep designing stuff, but at some point something's got to go at the door so we can start collecting y'all's feedback on what we should be improving in the process of adding the things that didn't get done in the initial. So yep, that's this is the Jeff Wilson version of the transmitter. We shot the engineers and started shipping.
Yeah, and to be super clear, this is a hard requirement for the product to have an audio player. So that's it's not like we're sitting here going, oh, should we do it? No, we definitely want to do it.
Yeah. Now the other cool thing is because it's basically a software-defined transmitter, when we decide how we're going to do the audio player software update, and pretty much anybody that's got the transmitter will have the audio player. So
yep.
You know, that's the other cool thing about this layout, is that we can add these features after the fact, and that's kind of neat.
We should keep rolling because
we're having so much fun.
I know.
Carry on.
Orban Inside, I can talk to this real briefly. I mean, we have the feature. It's what we've done in the past with the VS, and we've had some hiccups recently. So some people who are waiting for their VX have had a delay there, but we think that we've got that nailed down, and we'll have that solved within a short time frame. So
I'll let you know, because as a guinea pig, that's what we'll be running up the hill tomorrow afternoon to plug in on 88.7 if you happen to be in Eastern Canada.
there you go.
Cove FM.
I think next slide.
So yeah, I can speak to this one. So the device that we're using for our PAs is new to us. It's a 65 volt ruggedized LDMOS. It's similar to devices we've used in the past, but it's just that next generation. It's able to achieve better efficiency through a little bit of higher voltage, and really it's a very robust device. I do like to tell the anecdote that I haven't been able to fail a FET so far, as generally speaking, when we see these fail, usually it's because it's arc welding something on the output. They are very rugged and are pretty tough guys.
Nice.
Moving through that, you'll see a pretty substantial change in our topology here, where each PA gets its own dedicated low pass filter, and that's primarily so that we can improve the consistency where we scale this device through all of the lineup that we're using it in, all the VX series, but it's also so that we can confine as much of those harmonic emissions to that, as close to that PA as possible. We have a lot of really stringent regulatory requirements, as I'm sure a lot of you are aware, and that really helps us to achieve really low harmonic emissions, well exceeding the regulatory requirement. Moving through, you'll see our combiner, that there's nothing too drastically new there. It's a Wilkinson design. And then underneath that combiner, you won't see it, but it's there. We've built a high directivity directional coupler for measuring our forward and our reflected samples.
What's the directivity on that? Because it was one of the bigger numbers I'd ever heard for a coupler.
Yeah, so our design target there was a 30 dB directivity minimum. So we're trying to do as best we can, and there's some sophisticated tools that I think we'll show in a later slide that have enabled us to do that.
Yeah. Now, Aaron wants to know if we've tried dead shorting the center pin to the shield on the RF output at 100% TPO, and that's kind of a standard test for everything we build.
That's my bread and butter. I've done that at every 15 degrees around a Smith chart several times, and I've yet to see any failure. We have a very reliable and sophisticated shutback protection that specifically catches those high VSWR events and completely cuts the drive to the PAs before they're able to do any damage. So
the mentioning around the Smith chart is key, because what a lot of people don't think about is if your reflected power is in phase with your forward, you've doubled the effective voltage at the or multiplied by 4 rather, because it's square law, at the output of the PA FET. So in phase reflected is even more dangerous to the device than out of phase reflected.
Absolutely. And just to end the note on that, shutback protection, I believe we're around 20 to 30 microseconds to trigger that protection. So we've used some very good analog circuitry there to be able to trigger that as fast as is electronically possible.
And by the same token, as the power, reflected power, and we may get into that in the control section too, but as the reflected power increases, we dynamically lower the forward to maintain. So
That's
what
correct.
we're talking about here is an actual bay fell off or a chunk of ice chunked off, and a fast surge, right?
Exactly. Yep.
Okay. Oh, my favorite new part of the transmitter right there.
Yeah, no kidding. This is awesome.
So yeah, this isn't really much of a technical innovation, but we had heard quite a lot of good stories about co-op students and new guys being hazed by soldering D-sub connectors for interlocks for days, and we decided to save them that headache and put a little terminal block connector in with the transmitter that allows you to just wire in either the jumper that comes with it or whatever interlock system your site is using. It's toolless. It doesn't require solder. So, well, not toolless. It requires a small flathead screwdriver, a little greenie, we usually call it. and you know, it's very accessible. Exactly. Jeff's got the tool in hand.
It works. It's great.
I've got a greenie over here too, but so William mentions that accidentally switched the coax switch on an NV10 running 5 kilowatts with no damage. Thank you. So yeah, and William Harrison, yeah, so you need not a number 2 Phillips, William, a number 1 Phillips and a greenie. Yeah, 2 tools actually, not 3. Oh, plus the hex key that we provide. So we're up to 3 tools. We're going to require a bag to carry them in soon.
Yeah,
All right,
we'll have to
moving
start
on.
shipping out the Nautel branded toolboxes.
A pocket protector to carry them in.
There you go. There you go.
It's a big bag.
So yeah, there's some general improvements. One of the first things that I was responsible for on the project was the design of our front panel user interface. So we wanted to improve on our previous generations with our 4x20 character crystal fonts display, as Matt alluded to earlier. We've now got a 320 by 240 pixel LCD display that is fully graphical, and we're able to draw a really nice user interface and really display a lot more information, a lot more user-friendly way on that display.
And the other thing too, the first thing you'll notice when you first turn it on, it's like, wow, that's bright, but you do have the ability to turn the backlight down too.
That's correct. It's important to highlight that there's 2 user adjustable functions there. You can turn your backlight down, and you can also adjust the screensaver time. So that display will shut off on a variable timer. I think we allow that to be anywhere between I think 60 seconds or even slightly less than that, all the way up to several hours, depending on what your use case is.
Yeah, and just tapping the rotary knob is enough to bring it back up. So that's pretty
exactly.
Cool.
And it doesn't do anything. If you tap the knob, you're just waking the display up. You're not inadvertently doing something that you regret.
That's correct.
Yep.
Moving to just a couple. Exactly. Just a couple of notes also. We allow control through our SNMP. We are running version 2C. So we'll be compatible with all that. We've got, I believe, the OIDs for all of the different things that can be monitored and controlled. And then we've also got our classic remote control interface. It has scaled down a little bit from what you will have experienced before with VS, but we still have 2 DB9D subs for digital inputs and outputs, and as well as several analog outputs for monitoring your forward power and reflective power. And those are, for the most part, user adjustable.
Next question, and nobody else has asked it, but I know it'll be coming eventually. Any plans to upgrade to SNMP v3 at any point?
It was on the original spec as something we wanted to do, but we scoped it out because we didn't feel there was an urgency around it. We like it because it gives slightly better security. There's passwords and things like that. But I'm going to use the weasel word. It's on the roadmap, but it's something we like the idea of. So we're well disposed towards it, and so at some point. And as Jeff has noted before, this is it's a software-defined transmitter. So we upgrade the software, you get SNMP3. So it's something that's not a hard thing to do.
Right, and that's what we're saying in the design process too. We get must have, should have, would like to have, and maybe someday are the 4 primary categories.
Must have, nice to have, and meh.
Yeah, pretty much. And on the rare occasion, I'll put my hand up or something, and Matt will say, not just no, but absolutely not. So,
yeah, when hell freezes over, yeah.
Something like that. All right, so front panel.
Yeah, so
I could talk to this if you want, or your choice. Yeah.
No, go ahead, Matt.
I designed it, so I'm just gonna jump right in there. So what we tried to do is put as much information in a compact format. It's live, so you'll see your reflective power, the temperature, your modulation, and the forward power changing over time, of course. And then up in the top, it tells you the P1 in the top left there is the first preset. And then you've got the name of the transmitter, which is CMIC, which is based on an island that's just down the road from here. and then it's got your the parameters that are part of preset 1, which is the frequency and the set point. And that's actually the forward power that's in the top bar, and the set point is shown right below the little transmitter tower there. And then obviously the time. The top banner, the dark blue top banner, is always there as you navigate to different pages. So you're able to sort of keep track of what's my forward power, what time is, and things like, and what preset I'm on.
And similar to the VS and the legacy transmitters that you'll be used to, if you're on any screen, you just hit the back button and you'll end up at this one eventually.
Yeah.
One other thing worth noting, because I'm not sure it's in the slide deck anywhere, you see the temperature in degrees C. Guess what we did for the first time ever?
And that's in the AUI. So I'm afraid on the front panel, I'm not sure if they've done it yet. But,
but on the AUI,
tried.
you can switch
on the
to
AUI, you can choose Fahrenheit. Yeah, it's a very.
Now, so Aaron puts a note in here. Please, for the love of God, if when you implement SNMP v3, make sure it's still backwards compatible with 1 or 2. So many remote control systems still aren't v3 compatible, and there's only one external translator device that's very expensive and doesn't work well. So
duly noted. And we're actually, we've done a first implementation of it, but in our beta testing, we got some pretty firm feedback that there were some aspects of our SNMP MIB that were not quite meeting the bar, and that's why we beta test. And so we're actually looking very
stellar, yes.
Yeah, so we're working very hard, because what we do know about SNMP is once you set your MIB, basically you cannot just rip stuff out and throw it away. You've got to really respect that that's the stake you've put in the ground, and everything else you do there extends what you already did. And you can deprecate, but anyway, so yeah, duly noted.
Yep. All right, moving on. So we got the buttons, and I actually like the buttons. I was a little hesitant at first. By the way, the USB button is not a button. That's just a plug fill in the USB slot.
Yeah, I had to work pretty hard to get that included. But basically, it's a dust cap. Obviously, there's voltage inside a USB, and if you get a dust build up there, if the fans are drawing stuff in there, you could get little shorts and bad things. I also think it looks much prettier. The RF on off and the remote buttons are dual state buttons. I think Justin is the one who tracked those down. Yep. Beautiful work. I'm going to let you talk about them.
Yeah, they're quite cool. I'm a big fan of them. So they have both a red and a green kind of LED for state, and the black that you see in there with the on text is actually a polarized filter. So it will display on when it's green and off when it's red. We wanted to be able to kind of, in the space we were given, provide as much information as we could and as much control as we could. And having those dedicated buttons for those functions is something that we thought would be really important. Versus
and for those folks that can't see red versus green, the ability to see on versus off was crucial.
Exactly.
A big factor. Yeah. Down below that, we've got the rotary encoder, which is also a press knob, and then the little back button. And so the rotary encoder lets you navigate through the various menus, and you select by pressing the button, and to go back up one step, you just hit the back. And we've found that, I think most people, and I think Jeff, this has been your experience, that it actually works reasonably well.
I was a little, again, hesitant about it when it first came out, because I was used to hitting up, next, down, check, check, check. And it's been really a lot more intuitive than I expected. And yeah, I've programmed half a dozen of these so far. William mentions had someone plugging their phone into a transmitter USB port to charge it. Hey, in a pinch, any port in a storm. Barry asks if it's able to show modulation as an analog display. And I see you've got the modulation down there numerically, which I assume is dynamic and tracks the modulation.
Only on the AUI. So here we were limited very much by, this is firmware programming that goes on here. So we were trying to avoid, so anything graphical on here is basically a bitmap that's placed carefully on the screen, and then the things that change are they're actually characters that are driven to the display by the code. And so for the modulation, we decided to, at least in this version, to keep it simple and stick with numbers. So we were building something from the ground up, so
Right.
we'll pick our fights. And in the AUI, it looks prettier, and there's room for improvement there too, I think, but it's what you're looking for.
And as with, I'll put the note in right now, but as with just about anything I'm involved in, at least, we are almost certainly going to run long on this, looking at the clock on the desk ahead of me. So just to give you the heads up, this will be archived if you've got a hard stop and need to drop out and then pick up the recording later. But let's carry on then. So we got the control in the UI. There's some really cool stuff too in the AUI. And this is sort of for those folks that have been hearing us talk about getting rid of Flash for, I don't know, 6 years now. It's closer.
Yeah, it's closer. Yeah. So this is the HTML5 AUI. In this particular layout, the layout that you see is actually configurable. There are up to, you can either have it in what I call the 1+2 configuration, which is what you're looking at, which is one big panel on the left, and then two panels, which you can see that have the X's on in their top right-hand corner on the right-hand side. So the modulation and the meter panels, and then we got the spectrum analyzer. Or if you've got a higher resolution screen or a wider screen, it'll go to what I call the 1+4, and you could have modulation, meters, alarms, and audio inputs as well in their own little panels. The whole thing is it's touch ready, so if you're on a tablet or a phone, you can it just works. And then otherwise, we've used the Flash AUI as the technical spec for what we've done here. And then, so what you've seen is a reimagined, if this is what it has to do, this is how we're going to do it now. And that's where our programming team has spent a huge amount of effort on this. And
the goal was basically, and not to take away from the entire AUI session next week, but the goal was really to minimize the learning curve on the user end. Yeah. And preserving the functionality.
And also a lot of the mental metaphors and the language. So, if we had used such and such a word to describe a certain area of functionality or settings or something like that, that we're not just sort of pulling the rug out from all of our users. So this I've spent a massive amount of time on this, and I'm very excited about showing it off. It's also important at this point to sort of highlight the fact that there are 3 layers to this, and one's the operating system that's on the transmitter. Then there's a middle layer, which is the data broker. So all of the information that the transmitter has and is supplying and things like that go to this broker in the middle, and then that's fed up to the user interfaces through the various communication layers. And that's also very important to remember, and it is part of the reason it's taken a while to do, because this is something that this actual code runs on a GV, it runs on a VS, it's going to run on an NV Lite, it's going to run on an NX. So it's very important for us to sort of be meticulous about getting it right.
Now, one question that Tim has asked, is there a way to monitor actual audio output for remote locations, whether visually or orally? And I know there had been some discussion about that through the AUI.
And I think that we referred to that as kind of confidence monitoring at one point. And you're talking, yeah, we want to do that, and certainly, in the backlog, but it didn't make it in here. Where we set the bar for ourselves is if it's in the current AUI, the Flash AUI, so then that's what we want to sort of, that's what we're shooting for. Going beyond that would be looking for trouble. We know that the most important thing is to retire Flash.
Yeah. And on that note,
amongst other things.
Elaine's put the comment here. Elaine is like my memory because she knows how terrible my memory is. But we're at the NUG, the Radio Technology Forum. We do the first day of NAB every year. If you're going to Vegas, sign up. That afternoon, we'll be doing a deep dive into the new AUI.
Yeah,
And so we'll have a whole lot of fun with that. Register for that fast. We are approaching our record for registrations, which means that seats will be getting scarce in a bit. But,
and the AUI, I think that I'm going to be demoing there will be the one that's on a VX. So the VX being the most portable transmitter we have right now, that's what I'm going to tuck under my arm and take into that session. So yeah, that should be fun.
And so Marco says he's going to throw you under the bus and ask about this AUI for older transmitters, like back to the original NV series.
Our goal is to have all of it, you know, so we have it working on the VS. The VS Beta 3 is, I think, minutes away from being available for the beta testers. The GV, we've got an alpha version running, which you'll be able to see at NAB, and obviously this one is running. And if you got more questions about the AUI itself, then the session next week will go into greater depth on the whys and wherefores of the timing. And right. And I appreciate everyone's immense patience and willingness to stay the course, but we're really so close. But our goal is to have, you know, NV Lite, NX, all of those support.
Oh, another good question from William. So the VS series, every year or two, you had to take the thing apart and replace the CR 2020 or 2032 coin cell. Yes, no, Justin?
Bye-bye.
I love that question. So yeah, we didn't like the fact that it had a battery either. So on our new exciter, we have gone away with a battery, and what we're using is a supercapacitor. So in fact, so long as the transmitter is plugged in, that cap stays charged, and I believe that gives you a week or more of persistence. And of course, the main persistence there is for maintaining the transmitter clock. So it's gonna ride you through even fairly substantial outages without ever having to trigger an alarm to be replaced in the field. So that's was one of our big pain points we heard from previous transmitters, and we've remedied that with a supercapacitor.
And back to the exciter controller, our RDS generator is included and dynamic?
That's correct.
Static and dynamic, cool. And Tim had asked, so visual, so there is a modulation monitor, and you can see it on this AUI, the bar graph over to the right is dynamic. It yes. Tracks modulation. So you do have visual indication of modulation, if we were being a little unclear about that. All right, yeah, moving absolutely. On. In the interest of time, we're going to have to pick it up, but I think we get some duplication here too.
Well, this just talks to the high point. So yeah, it's I think it underscores some of the things we've said, so we can move on.
Yeah, and so this is something interesting and new. This is just a sneak preview. I'll let you have this one.
Yeah. So one of the things we wanted to do is to be able to offer people something that is a modern and very flexible way of doing controlling main standby and N+1 systems. And so we've partnered with a company here in Canada called Davicom, and we've licensed their Cortex 320 and pre-configured it and obviously rebranded it as a Nautel device, which we're calling the SC4 controller. And you're actually the first people anywhere to hear about this publicly. It is SNMP based. This particular unit will be in the rack at NAB, and there are two VX600s connected to it in a standby mode, main standby setup. And it features an HTML status and control panel. So you can connect to it remotely, locally, on a laptop or whatever, and it gives you that option to sort of, when you're buying the unit, to sort of have that just ready to go when you get it.
Now it works over SNMP, yeah?
Yeah.
So there's no reason, or is there any reason I couldn't plug it into like a VX2 and a VX2 or a VS2.5? Could I run it on a VS transmitter?
Offhand, I can't think of a reason. I think as long as it understands the,
You may need to load the MIBs for it, but beyond that.
yeah, you definitely, I think the DAVCOM understands different MIBs. I don't think it requires that you be using the same exact transmitters. So but I'll find out about that. I think that's a good question. So
All
yeah,
right, so you
yeah.
find it out. I'll let William know, and we'll figure it. And if we can't, then that'll be on your list of things that need to be addressed.
And that's pretty much it. Sales has the pricing and things like that. So, availability would be almost immediate.
Don't ask me what the price is. I haven't seen the price yet. All right. So technology tour. So this is where we started. And Matt, I'll let you talk through these ones. But
Sure.
this is just sort of the recap of where we started and where we went to.
Yeah, and this is the exciting part where kind of here's the VS series. So there's a 300, there's a 1 and a 2.5, and the secret 150. And so if we look at that, that translates almost directly over to 3 models that we have in the VX series with 300, the 1 and the 2. And if we click again, and what this has done is given you an affordable alternative to those VS units if you're an analog company. And then in addition to that, we've added the 150 at the low power end, a 600, which is in that intermediary, which is actually pretty handy little power level, and then a 1.5 between the 1 and the 2. And then beyond that, one of the big things that we're talking about here today, but haven't talked about much yet, are the higher power ones from 3 kilowatts up to 6. And we're going to see those in a couple more slides. But the idea is that from the very extensive 11 models that are available in the VX series, you should be able to find something that meets your needs and your budget.
And historically, that's been one of our bigger challenges. If you needed 500 watts for a translator into a single bay, we had a gaping hole. You needed a kilowatt transmitter. So like the 600 fills that gap nicely. And this was, the goal was to hit the numbers that folks have been asking for several years.
Yep.
Now this is the cool one, and I'm going to give this one back to Justin because this thing makes me happy inside. So tell us a story.
Yeah, so this slide I could go on for days, but it really speaks to our rigorous design and the amount of care and attention to detail that we put into just about every aspect. What you're seeing in the pictures below is airflow simulation. We did many hours of airflow simulation to get everything just right in this transmitter, between dividing up the air that's going through our heatsink and then the air that's flushing through the rest of the transmitter, making sure that our fans are properly pressure optimized for the impedance that they're blowing into, verifying that our thermal models that correlate our fan speed are accurate so that we can adjust our fan speed based on the amount of dissipation that our PAs are experiencing. That all of that went into getting the best thermal solution that we could for this very compact transmitter size. One thing you'll notice is that the fans are positioned at the front as an intake and then blow through the heatsink. When we were studying our kind of lifetimes and our MTTFs, a even modest increase in temperature of fan bearings can substantially decrease their MTTF, mean time to failure. So we looked at that really closely because we've seen a lot of equipment that draws air through the transmitter and through the fan, and even experiencing that 10 to 15 degrees rise is substantial in the fan life. So we've positioned those as an intake, so they're always getting the coolest air and their bearings are experiencing the best lifespan we could possibly give for them. Speaking to our MTTF for our FETs, we've done a very conservative design and maintained a 250 million hour mean time to failure with regards to our FET performance. So that's based on an electromigration within the FET that would cause degradation over time. So that goes back to just making sure that when we're designing something, that we're designing it for the decades that we anticipate this equipment to be out there, because we've certainly seen that over the life of the company.
And that's something important to note, because like there'll be a lot of times you'll hear somebody talking and they'll say, yeah, this amplifier's got a spec output power of X watts. And but if you run it at X watts and you're running it that hot, it may live 6 months as opposed to 6 years. So when you're designing, you're not just designing for a mean time between failure, an MTBF, you're designing for the MTTF with the assumption that it's going to live this long. And that's a unique philosophy that I think is worth talking about.
Now, really, it's about going beyond that data sheet. So many designers take the data sheet at face value, but you have to understand the actual mechanisms that wear on equipment, and know what the data sheet is promising is not necessarily what is going to be suitable for your product.
Yeah. John Welton makes the note of the fact that the circuit boards in this thing are bright red as opposed to the usual green or blue, and he wants to know if they're faster.
We did a detailed study that suggested that you get at least 110% speed from red PCBs. Now, I'm joking with you guys, but what we did, because this was a ground up design, we wanted to internally be able to easily identify a VX circuit board from maybe a legacy circuit board, and B, we just thought it was kind of neat looking, honestly.
The one that has the racing stripes runs faster. Yeah.
Yes. And we take no responsibility for what happens if you all decide to overclock it.
Yeah.
All right, moving on with the modeling.
Yeah, so I just talked about a lot of thermal modeling. We've also done a lot of complex EM modeling. So you'll see in that top left-hand picture, that's the directional coupler that I spoke to earlier. And really, there's snowball's chance in heck that we can just make that kind of a design without a very sophisticated tool. So you're seeing there the actual field density through the directional coupler. So it's a kind of coplanar design where it's a track conducting the main current with ground planes on top and bottom. So there's a lot of very sophisticated geometry there that has gotten us to that directivity that we're really proud of achieving, 30 dB. And that is getting our performance numbers. And then you see kind of in the right picture is a mesh for our Wilkinson combiner, and then in the bottom, I believe, is another mesh that I think includes our PA and our low pass filter. But it's really cool and really powerful, the tools that we've got at our disposal now to do these simulations, and we're definitely deploying them to produce even better designs.
William asked if we can ship them with a spare air filter so they can always have a clean spare on the shelf. And I mean, that certainly we can add that option. Talk to whoever quotes your transmitters, and we can certainly package them in there. That's easy to do. We do keep the media. Did you account for dust collection and problems? So the airflow is one thing. What else have you done to try to minimize dust buildup?
Yeah, so that's really great. So with regards to accounting for the amount of dust buildup on the filter, that's pretty variable. So what we've done is we've looked at that. We've said, how much can we expect this impedance to change over time, and adjusted our fans accordingly. But the other kind of backstop to that is that our fan control is always looking at the actual dissipation of the PA. So if we experience a substantial airflow impediment, say, your site door is open and you have a bunch of leaves get sucked in, and the transmitter fans will want to hold on to those for dear life. Our PAs will actually, as the temperature increases and efficiency gets worse, our thermal control system will limit the dissipation of the PAs such that we don't experience any degradation. So you will experience a foldback in output power and an alarm that corresponds with that, but you will stay on air, even if those thermal conditions start to get to a point where the transmitter has to fold back to protect itself.
And did I see rightly that the fans also work a bit harder? Like if I put my hand over the fan, it sounds like it's sort of powering up to go a little faster. So
yeah, so that generally is related to just the pressure characteristics of the fan, but the fan speed is variable, and we do ramp them up accordingly to that temperature and that dissipation on the heatsink. The other big thing that I want to highlight is the positioning of those fans at the front of the transmitter that is filtered. Those create a positive pressure throughout the entire cavity of the transmitter. So that is provoking airflow out through any seams or any gaps, or even the USB port that Matt mentioned earlier, such that we're not sucking dust into our system through all of those small kind of orifices, but we're actually pushing it out. So that positive approach to airflows is big in preventing dust accumulation.
Well, and that's one of the critical things. You'll see designs where the fans are at the output and they're pulling the air out of the transmitter. And the argument, we're pulling the heat out. Well, two things. Number one, you're running heated air over the bearings, so you're reducing the fan life. And number two, you're pulling unfiltered air in through every crack and crevice in the transmitter. So, so absolutely putting the fans at the intake side and blowing the air in through, and that way cool air going over or cooler. So it's kind of cool. Let's see. So John gets to be Adam at the moment. Do we want to mention fan failure behavior and how it'd be a proactive approach to fan failure management? Tell a story. I see Justin's nodding already.
Sorry. So yeah. So in the VX2 and below, so the 150 to 2 kilowatt, we have two fans. Those two fans do very different jobs. One is principally circulating airflow through the bottom of our heatsink, and the other fan is feeding air over the heatsink through the low pass filter and through the rest of the chassis of the transmitter. So that was necessary to get into the form factor that we are and get the cooling performance that we need. That means that if a fan fails, we do have to shut down the transmitter to assure that we don't affect reliability and cause any other failures throughout the system. However, what we've experienced with these fans is over time, as that bearing fails, it's going to generally work harder and harder and slow down as the bearing, and usually make a lot of noise as the bearing's going. So we have a alarm that we've actually added here to indicate that the fan is slow. So there's a threshold speed that we actually say, hey, the fan's supposed to be running here, but it's running there. And we can trigger that alarm to proactively indicate that, hey, you might want to check this out and consider taking a fan up with you. So we've tried to do our best there. In the VX3 to VX6, we actually tolerate, in that power block section, there's 5 fans, and we can tolerate a fan failure there. So there is that level of redundancy in the higher transmitters.
William asks, on SWR, if an SWR condition is encountered, will the VX fold back in a better fashion than the VS series? Because if a VS encounters a high SWR, it'll often shut off completely, even if the output power has been set very, very low. And that's kind of that's a double-edged sword, because there's two things you've got to look at. You got to look at absolute reflected power as it threatens the PA, but you've also got to worry about the threat of oscillation if you turn the power down too low and hit reflected. So it is a challenge. Now I can tell you for flat out on the VS1, if you set it to 75 watts, it will run into a paper clip. And I've done this. I've also run it into a 2-bay Shively with 2 inches of radial ice at 75 forward and reflected. So they do have power levels, even the VS, that you can set that they'll run through almost anything. But you can't rely on them to reduce to that. You almost have to manually select that preset. So now, having said that, is the protection circuitry in the VX much different or about the same?
We've gone for mostly a kind of copy of what we've done before on our protection, because we know that it for the most part it's worked. We've got that fold back into VSWRs higher than 1.5, maintaining that absolute reflective power. Like you just spoke about, we do have a shutdown into SWR greater than 3 to 1, but of course that is very dependent on what the transmitter is measuring in terms of SWR. That's where you can find those conditions where sometimes if you dial up low enough, it might still work. But that's, yeah, mostly what we're concerned about is those two factors that you alluded to, is the actual survival of the amplifier, but also our stability. because we can't guarantee stability necessarily into VSWRs that start increasing and higher than 3 to 1, and making sure that you're not putting garbage into other people's bands. So that's pretty critical that we don't allow that, because that's going to start to get you some really bad eyes on your station.
Right. And now, since I know he's online and he's already outed himself in the chat, William, I'm going to get you to reach out to support@nautel.com and ask for Adam Middlecoop, because Adam's online and listening right now, and talk to him about the VS2.5 you're referencing in the questions, because we'd like to get that working for you the way you want it to. So there you go. I'll hook you and Adam up, and we'll get her done one way or another. All right, moving on. So long life design, we've talked a lot about MTTF versus MTBF, and what other things have you done?
I don't think we need to dwell on this slide at all.
Hey,
I think Justin has covered
it all.
Yeah, because we're at 2:15, and I think this one's a good one.
Yeah.
Justin.
So specs, we got some good numbers here.
Yeah, so what you're seeing is kind of what maintains to be our industry competitive audio specifications. So we've maintained our really excellent composite SNR and our stereo SNR. We've got pretty much, there's no surprises here. We haven't really changed much, because we've already been at a very really competitive audio spec, and a lot of work goes on in the DSP kind of processing side, where all of this is mostly software defined in terms of our stereo generator and all of our filters and that sort of stuff to make a lot of this happen. And it's very impressive that we've been able to achieve all of these specifications.
Cool. And I mean, yeah, the numbers, I mean, they kind of speak for themselves. There's not much else to say there. Now, back panel, this is a busy back plane.
We did not have a lot of extra room to spare, is what you'll observe, because primarily we wanted to enable easier interfacing between our transmitter and your other site equipment. So previously, where you might have seen some of your audio sources on breakout cables from D-subs, we've tried to make it more accessible, so that we're taking our analog audio in on XLRs, and we've got BNCs available for 2 composite inputs. And then we've actually also gone from a single digital input to 2 digital inputs. So now you can actually have both your main and backup audio be digital if that's what you desire. So I don't know if we need to go into every connector, but we've made everything as accessible as possible on this back panel to just make it a lot easier to service your transmitter and make sure that you don't have to take it out of the rack.
And thank you for going XLRs on analog audio instead of making me solder it to the DB9.
Yeah. And I think while we're here, we can see that between those 2 XLR, the 4 XLRs, there's the SD card, and that's our whole operating system and settings and everything. And I think that's worthy of a mention, that's what we've put there. It has all of that. With the transmitter off, you can pop it out and make a clone, so you've got a backup. So I think that's a pretty exciting difference that we've made with that.
Yeah. Actually,
sorry, Marco asked why we didn't use the RJ45 Studio Hub connection for the audio, and the big challenge, Marco, is that it's not an industry standard by any stretch, so there are a lot of folks that still struggle against stuff like that. So I guess what is it? You try to satisfy as many as you can.
And just to speak on that SD card for a moment as well. So we've always had flash storage on our exciter controllers. Previously, it was a chip soldered to the board. So the SD card enables us to use a removable media that, in the case where you have some catastrophic failure in software, or when that flash eventually loses its life, because all flash has a time dependency that after so many reads and writes will degrade. Being able to remove that means that we don't have to trash or do an OS recovery or replace a fairly substantial costly component. So we definitely, like Matt said, advise that if you can make a direct clone of the card, that is a great way to create a backup. I will advise that the file system that we use on there is Linux suitable. So when you plug it into a Windows machine, you're not going to see like typical files. I wanted to make sure that was clear. So don't panic if you don't see any files, or your PC might ask you to format it. Don't do that either.
Don't be doing that.
Don't do that either, but you want to use, we have a cloning procedure, and we advise different software that will help you do that. And what that's doing is making a bit for bit image of the actual card.
And I've used the software, and I'm not a hyper technical person when it comes to that stuff, and I found it really straightforward. There's some excellent software out there where you just, you can just do the clone, and it's and Windows doesn't have to understand what it's doing. The software does, and that was a good thing to do. The peace of mind is great. Let's roll through these next couple of slides reasonably quickly, because
we're already 20 minutes past the top.
And these are all available on the website, so you can go in there and download them. And so here's a good shot of the new 6 kilowatt unit, and I'll talk to the high little bits and pieces. The exciter controller at the top is a little bit lighter than the 2 kilowatt, which is in the at 15 pounds. And then the power section with all the power supplies in place is 65 pounds. If you pop them out, you got 50 pounds. So as someone who's at a site on my own, I think I might use the technique that Jeff suggested, which is to put a tray in there and mount it up that way. So, it will hold itself from the front panel. But I think if you've got vibration or an active site where there's people bumping into it, I would probably stick a tray under that to take the weight, or some kind of support for the back end of it. Otherwise, everything else is very similar to the 2 kilowatt model.
Very cool. I mean, specs are pretty basic. There's not a lot to talk to there. Power consumption, the efficiencies. 70% across the board.
And these specs are also on the website already. They are draft, but they're a very late draft. So they're, you can go and help yourself to these and have a good look at it. So these are all the different roles that the transmitter can play. Obviously, I think there's no surprises there to anyone. We do have the 150 and the 300, which are certified for LPFM use. So, I think that's a good range. This is really the summary of all those things. We've talked to basically everything there. The 150 to 2 kilowatt models are shipping now. And then the 3 to 6 is in kind of the final stages. And so you can come and have a look at a full, not quite fully working, but mostly fully working at NAB. And I think in the first half of this year, we'll see this.
And I'm a little cynical, so I would say by end of June for the 3 to 6 to start shipping, and then we do have a backlog. But having said that, if I quoted you one today, it's going to ship this year sometime. So, all right. Cool. I like this one just because it's got colors.
Yeah, really. And I can speak to this, and this ties back to the question that Jeff asked about HD. And if you look at the top range, you've got the digital focus, which is HD. We've got the VS rack mount there. We've got the GV. We've got the MV Lite, which is in that gray zone because it's upgradable to HD if you want to. So it sort of covers your bet. And then down at the bottom left is that we've got the VX series, which, as we said, is very purposefully targeting the analog range between 150 and 6 kilowatts. So I think that's pretty exciting.
Look. Hey, if you got questions, this would be the time to ask them. So really quick, without giving away too much of the shiny stuff, talk to NAB, Matt.
Sure. So we'll be in the booth that's indicated there. If you're real quick, you can use the free exhibit passcode down at the bottom there. It expires tomorrow. And so that's good. The various events that we've got are the Nugget NAB, which is the Radio Technology Forum, which is at the Flamingo. And also at the Flamingo will be 2 other sessions. One is my AUI session, which will be a hands-on Q&A, talk as long as we want kind of deal. And then there's also at the same time is the HD session with Phil Schmidt, our CTO. Obviously the booth, you're welcome to come by, and I think there's actually 2 events that will have possibly cake as well, and possibly refreshments. The products that you'll see are the ones listed on the list on the right hand side, and so VX, GV, and AirChain, which there's an HD AirChain announcement webinar next week on Thursday, so you might want to put that into your schedule as well, and that's pretty good.
Yeah. Now, before we get off of this too far, one of the things when you open the box on a VX, the first thing you see is 2 cardboard boxes. One contains the ancillary kit that's clearly labeled. The other one has got the quick start guide and a USB stick. And I've got that USB stick plugged into my laptop right now. And if you plug it in and click on the word index, you get something that looks like, well, let me go to the home page. Sorry, we were playing with it. So you get something that looks like this. And this is, so all of the documents are on the USB stick, but through a browser, they're very quickly searchable. So it's just one of those cool things that's changed. I was picking on Adam earlier with respect, because hey, the support guys jump onto a webinar, boy, they become targets. And we've got different videos. Adam stars in a couple of the unboxing video. You get to see him explain how to get in and do the first time setup. There are a lot of videos on like swapping out circuit boards and things like that. So you can just go in and run them. There's no sound on this one, so I'm not distracting myself. I can let it run in the background, but just try to really make it a whole lot easier from the perspective of, you know, the guy who maybe has an IT background and has got stuck with maintaining this RF generator, this AC to RF converter, without a whole lot of RF experience. So we try to give you some different input on the things you can do to make that a little easier. All right, so that's just one example. Matt, you look at one.
Yeah, I was just going to say, and one of the reasons that these videos are possible is that when we're designing the product, we're actually modeling them in CAD, of course, which drives, you know, the creation of the chassis and, you know, various boards and blah blah blah. But what we end up with is actually a very detailed 3D model of everything. Which then we're able to take into a different software, which is this composer software, and allows us to do this 3D animation, and to, rather than having someone's hands in there and, you know, trying to do it live, this allows us to do some very clean examples of how to do this thing and this task or replacement and so on. So I think that that's a really good leveraging of the tools that we're using for design work to then be able to bring it forward into the training side of things. And we've covered off, I think, pretty much all the main things that you would ever need to do for this. So I think with the team, both the team doing the support team that did the unboxing and the first time setup, and also these other ones, excellent work.
Yeah. So it's just been a great tool to have in that regard, and it's stuff again that we can do now that we couldn't even think about doing shooting 15-20 years ago. Lots of online information. We got the mandatory stuff there. We're at the bottom of the hour, so on that note, I'm going to say a big thank you to Justin Jamieson for all the tech time and giving us an hour and a half of your day. I'm going to say another thank you to Matt Herdon, who gave us an hour and a half of his time yesterday to learn about Teams, and now I'm getting a productive hour and a half out of him for today. And absolutely, 70 folks stuck with us to the bitter end, and we hit close to 100 earlier on. So I want to thank all you all. Hope to see you at NAB. Again, we've got a TTT session coming up. We've got the GV HD launch webinar coming up. It's going to be a busy month, but we hope to see you all later.
Awesome.
Thanks much.
Yeah, really good.
Have a great day. Bye now.
Thank you. Yep. Bye-bye.